and keep the social distance by stretching. And I thank you and goodbye.
Hi everyone, I'm Shashi. And Simon says don't touch your face, your eyes, your nose, and your mouth unless your hands are super clean. Bye!
Morning grade 12s. This is the second session on vectors. Today we're looking on page 30 out of the textbook, and we're specifically looking at scalar products. What is the meaning of scalar products? Now scalar product is basically A dot B. We read it as A dot B. So you have a vector here, A1, A2, and we have a second vector here, B1, B2. So this is a column vector and it's just now in 2 dimensions, X and Y. The formula for scalar products is A dot B is equal to magnitude A, magnitude B, cosine theta. This is the basic formula that we're going to use. So there you have your formula. A dot B is equal to magnitude A, magnitude B, cosine theta. But what is the meaning of this now? Now, we can work with the column vectors, or we can work with our base vectors, where we say that this is then I plus J, when we work with those base vectors. And the base vector is then A dot B means II plus JJ plus KK. This is in 3 dimensions. I'll show you just now the meaning of this. So that means now you actually have I, J, and K. There's your column vector. So it works in 2 dimensions, but it's also going to work in 3 dimensions. We're going to do it in the 3 dimensions right from the start. Then you have magnitude A. Now the magnitude is the length of your one vector, your first vector, which is then I squared plus J squared plus K squared. Then we multiply it with the second vector, so it is also I squared plus J squared plus K squared. And then we have to find that angle. We actually want to find the angle between 2 vectors, cosine theta. So this is the meaning of A dot B is equal to magnitude A, magnitude B, cosine theta. Now let's look at an example, and then you will understand it better. Let's say we have the vector, you can follow there in the books as well. Let's say we have that vector 5, negative 2, and the second vector is, so this is P, and this is Q, and this one is 0, 2. So that is our two-column vectors. This is in 2 dimensions, x, y, x, y. Now, what we want to do now is we want to find the angle between these two vectors. So this is the vector P, this is the vector Q, and we want to find that theta there, that angle. That is the whole purpose why we're going to do it. So now we say, what is the formula that we use? A dot B is equal to magnitude A, magnitude B, cosine theta. This is the formula, the one formula that you need to know. What does A dot B means? We said now this is II plus JJ. This is now in 2 dimensions. So what is II plus JJ? II plus JJ. So it's going to be 5 times 0 plus negative 2 times 2. II plus JJ. So here you multiply the two vectors with each other. Then we have the magnitude of A, which means this is now only, in this case, going to be P, the magnitude of this vector, which is then 5 squared plus negative 2 squared. Make sure that you use your signs correctly. And then here, this one is going to be the magnitude of 0 squared plus 2 squared cosine theta. This is what you want to calculate. So with algebra, we're going to find the values now and also bring this over so that you can get the angle cosine theta. So this is 0 minus 4, so it is negative 4. And this one is now, so you have to calculate the magnitude there. Use your calculator. I have the square root of 29. So to get rid of it here, I divide with that. And that one is then the square root of 4. Okay. And now to get that angle, you will say negative 4 divided by square root of 29 times square root 4, and then remember to find the angle, it's a second function. So you have to press second function cosine to get the angle there. And this angle is then 111.8 degrees. Try it on your calculator and see if you get the same answer. Now, because of that negative, that's why I can immediately see that this is going to be an obtuse angle, because there's a negative there, that negative cosine. So don't throw it away. Make sure that you have it. This works exactly the same in 3 dimensions. We're going to use exactly that same formula there. You will see in the textbooks we have very good examples now. And the exercise that I would like you to try now is exercise 7 on page 37. I will also write it down so that you can follow then if you don't have a textbook. So first do it and then you listen further. So the first one says I have the vector 2, 4 and 3, negative 1. So this is still in 2 dimensions. Now we must find the angle between these two vectors. So this is what we want to find, that angle theta there. The vectors will go outside, arms out there. How do I get angles? I have my one formula that I'm going to use. A dot B is equal to magnitude A, magnitude B, cosine theta. There's that one. So what does magnitude means? II plus JJ is equal to the magnitude of I squared plus J squared times the magnitude of I squared plus J squared cosine theta. Finding that angle there. Okay, so what is II? II will now be 2 times 3, which is 6, plus 4 times negative 1, negative 4 over, and the magnitude here is now 2 squared plus 4 squared. So it's the magnitude of 2 squared plus 4 squared times the magnitude of 3 squared plus negative 1 squared is equal to cosine theta. So to find your angle there now, first you have to do these calculations. It's a good idea to always write it down. We have then 2 over the square root of 20 times the square root of 10 is equal to cosine theta. And now you can press second function cosine 2 divided by square root 20 times square root 10, and my answer is 81.9 degrees. Make sure that you get that same answer there. Okay, the next one is number B. This column vector is 5, 2, and the second one, negative 3, 2. I have to find the angle between these two vectors. So that is the angle that you want to find, arms out. What is the formula? A dot B is equal to magnitude A, magnitude B, cosine theta. That is your angle then there. So now I have to do that. What is the meaning? II plus JJ is equal to I squared plus J squared times I squared plus J squared cosine theta. And now we're going to do those calculations. 5 times negative 3 is then negative 15 plus 4 over 5 squared plus 2 squared gives me the square root of 29. And negative 3 squared plus 2 is the square root of 13 is equal to cosine theta. And now we can do the calculation. Second function cosine, you divide here. My answer is 124.5 degrees. Again, there's a negative there. That's why I have a negative answer here. It's an obtuse angle that you will get there. Question 2. In a triangle, okay, now they say A is the point 32, B is the point negative 13, and C is the point 17. And they want you now to find the vector AB and the vector AC. We don't have them at this stage. You have A, this is actually OA, OB, OC. So to find AB, and this is now a very important step, we've looked at it the previous lesson as well. It is the last one minus the first one, so it will be OB minus OA. If we make a mistake there, everything is going to be wrong, so be very careful here. So I can write coordinates as column vectors. We said that also in the previous lesson. My coordinates can change to column vectors because it's from that origin. It's a position vector that we have there. So this vector A is then 3, 2. And the vector B is negative 1, 3. And the vector C is 1, 7. 1, 7. So to find AB now, it's OB minus OA. So OB minus OA. So negative 1 minus 3 is negative 2. And 3 minus 2 is 1. So this is the vector AB. There's the vector AB. Now we want to find AC. So AC is going to be OC minus OA. OC minus OA. So 1 minus 3 is then negative 2. And 7 minus 2 is 5. So this is the column vector for AC and the column vector for AB. So if we want to find that angle now there, theta, remember it will be, they say find the angle between AB and AC. Now that means A is in the middle. AB and AC, arms out. Okay, so we have the two vectors. What is the formula? A dot B is equal to magnitude A, magnitude B, cosine theta. What is the meaning of that? Here's the two vectors now that we are working with. So A dot B is II, so it is negative 2 times negative 2 plus JJ, 1 times 5, is equal to magnitude. Magnitude is the length, it's always Pythagorean, so it's negative 2 squared plus 1 squared, and then I multiply it with this one, negative 2 squared plus 5 squared cosine theta. So we want to find cosine theta. This is the purpose. We want this angle here. So II plus JJ plus KK, and that gives you then 13. No, it seems to be that here's a mistake. Let's just go back to AB. The vector AB is then OB minus OA. So it is negative 1 minus 3, which will be negative 4. Negative 4, 1 there. So this will then be negative 4. Sorry, that's how we get the 13. So this is also negative 4 squared there. So that gives us the magnitude of 17 times the magnitude of 29. And in your last step, second function cosine, and the angle is 54.2 degrees. 54.2 degrees. Now when we go now to question 3, now we're going to look at 3 dimensions, but it works exactly the same. So the first one here is 12, 1, negative 12, and the second one is 8, 4, 1. So the formula is still going to be A dot B is equal to magnitude A, magnitude B, cosine theta. So all the time that is the formula that we are using here. Now what is II plus JJ plus KK now? So now it is II, which is 12 times 8, plus 1 times 4, plus negative 12 times 1. Okay, I'm going to bring this down immediately, is equal to cosine theta. So now Pythagoras is going to be all 3. So it is 12 squared plus 1 squared plus negative 12 squared. This is not 0 here. And then the second one, you multiply here, is 8 squared plus 4 squared plus 1 squared. So cosine theta, it's always good to put that step in between so that we don't make mistakes there. So this is then 96 plus 4 minus 12 over the square root of 81 times 17. We already got the square root there. And then second function cosine, and the answer of theta is 54.9 degrees. So it works exactly the same with the 3 dimensions. Right, the next one is now number B. This one says 4, negative 1, 8, negative 8. And the second column vector is 7, 4, negative 4. Okay, so the formula that we're going to use is A dot B is magnitude A, magnitude B, cosine theta every time, that one formula that we are using. Right, what does A dot B means? I, so 4 times 7 plus JJ, negative 1 times 4, plus KK, negative 8 times negative 4 is equal to, now when we get the magnitude, you work with one column vector, with your one column vector there. So this is going to be 4 squared plus negative 1 squared plus 8 squared times the second vector here, 7 squared plus 4 squared plus negative 4 squared cosine theta. Cosine theta. So eventually cosine theta is equal to, so we do our calculations here, I have 56 over the square root of 81 times the square root of 81. You can change it to 9 if you want to. And then second function cosine, and the value of theta is 46.3 degrees. I hope you are sure of getting these angles, because this is the basic concept. There's a few things coming up, but this is what we really want to do. Right, and the last one that we're going to do there is number 4. It says in triangle PQR, P has the coordinates 5, negative 3, 1, so it's 3 dimensions. Q is negative 2, 1, 5. And R is equal to 9, 5, 0. So again, we can change from coordinates to column vectors, and you can change from column vectors to coordinates. That's also a question that they ask you sometimes. So this one as a column vector is negative 2, 1, 5, and this one as a column vector is 9, 5, 0. 9, 5, 0. I can also change it to base vectors. So this is 5i minus 3j plus k. And this is negative 2i plus j plus 5k. And this one is 9i plus 5j. There is no k, k is 0, so I can omit it. I don't need to write that down. And we want to find the angles of the triangle here. So we're going to use the same method now to find the angles. So you need to find the column vector PQ, and we'll have to find QR, and we'll have to find PR. Now remember, your angle is always there in the middle. So if I want to find Q, PQR, then I will have QP and QR. Can you see? And if we complete the triangle now, if I want R, then it will be RQ and RP. And if I want P, it will be PQ and PR. This is how I will calculate those angles there. We can also call it alpha, beta, and theta, but you will have to have 2 angles there, and the arms are out, so it's always good to draw the picture. Now, if we do these calculations, we find that P is equal to 90 degrees. Q or R, you can calculate any of them, is 45 degrees, and then obviously the third one is also going to be 45 degrees. So we will calculate them with exactly that same method that we have there. I would like you now to look in your books on page 39. We're looking a little bit at the laws of the scalar product. So what we say is A dot B is the same as B dot A. This is the commutative law that we've learned already. And then A, and then dot B plus C, this is the distributive law. So this is A dot B plus A dot C. So you can also do it like that. What's very important now is the following one. If A dot B is equal to 0, then our vectors are going to be perpendicular. So this is a very important thing that we're going to use here. Okay, so the next exercise that we're looking at now is exercise 9 on page 39. Page 39. Exercise 9. I'll write them down, so if you don't have the book, then you can also follow. So the first one is A is the column vector 3, 2. B is the column vector 5, 3. And C is the column vector negative 2, 3. Again, first do the exercises and then you mark them. So the question is now calculate the magnitude. Magnitude means, they can also ask it like this, the magnitude of A, the magnitude of B, the magnitude of C. That is what we do. And this is Pythagoras. So it will then be 3 squared plus 2 squared, which is equal to the square root of 13. You can get the value there, or you can give the answer like that. Now, B will then be 5 squared plus 3 squared. And that is the square root of 34. And C is then the square root of, make sure here with your signs, negative 2 squared plus 3 squared. And that is giving you also the square root of 13. As I say, you can get an answer, round it off to 3 significant figures, or we can give it like this. At number B, they ask now, calculate the scalar products of A dot B, B dot C, and C dot A. So we have to get the scalar product of each one then there. So what would be the scalar product of A dot B? II plus JJ, isn't it? So this is 15 plus 6, which is 21. And B dot C, it is negative 10 plus 9, which is negative 1. And then A dot C is then negative 6, positive 6, which is 0. So A dot B, the scalar product, just getting those scalar products there. Then they ask you which of the pairs of vectors are mutually perpendicular. And it will be this one. If A dot B is 0, then they are perpendicular. That's a very important fact there. And then they say find a vector which is perpendicular to B. Now, when will I get from 5, 3, let's just write it down here, B is equal to 5, 3. When will this vector be, or which vector will be, will make sure that this will give you a perpendicular one. To get a perpendicular one, it means that this vector that we're going to give us here, II plus JJ, must give us 0. Because if A dot B is 0, then they are perpendicular. So when will I get that? Negative 3, positive 5. Because then you have negative 15 plus 15, and that will give you the 0. There's more than one possibility, because this can also be positive 3, and this one can be negative 5, but that will give you that answer there. Right, the next one is question 2. A is the vector 2, 2, 1, so it's a 3-dimensional one. B is 1, 0, negative 2. And C is 4, negative 5, 2. So there's my column vectors in there. And now they say calculate the column, the scalar product of A dot B, B dot C, C dot A. Same that we did in the previous one. This time it's just in 3 dimensions, in the 3 dimensions. So this will be 2 plus 0 plus negative 2. So this one is going to be 0. BC